Welcome everyone. Welcome to this presentation by Leah Beesley. Firstly, I'd like to introduce myself. I'm Emma Ewan, I'm the Regional Manager for the CRC. I'm based out at UWA, which is also where Leah's based. So we're kind of
funny that we're meeting here.
Funny that we should meet the first time here. But yes, so welcome to this presentation. I'd also like to acknowledge that we're meeting on our land and to pay my respects to the elders past, present and future. And I'd also like to give thanks to the board agencies of the new waterways who's supporting these presentations. And for those who don't know, that is the Department of Biodiversity, Conservation and Attractions, and I saw someone on the lift from there, so welcome. Also Department of Planning, Lands and Heritage, Department of Water, Environment Regulation, UDIA, Western Australia, the Water Corporation and WOLGA. And as I mentioned, today we've got Leah Beesley. She'll be presenting on repairing urban waterways using the Restore tool. And if you could perhaps make her welcome.
It's nice that it's a small group. I sort of adapted this presentation from one I gave to the CRC about a month ago. Just got a little bit more time so I can sort of flesh it out a little bit more today with you, which is going to be really useful. Just to give you a bit of an overview about what I'm going to talk through in the next 30 to 40 minutes. I'm going to talk a little bit about the project that created these management tools and provide a little bit of background about that management need. And then I'll talk through the 3 decision support tools that the project created. So there's this Restore sort of Excel tool, which is a beta version. We've also got fact sheets and riparian guidelines. And all of these are available on the CRC website. So firstly, these tools were developed inside Project B 2.2/3, and the title of the project was the Protection and Restoration of Urban Freshwaters to Inform Management and Planning. So our goals were to support regional decision making. There's a lot of recognition that sometimes how we manage urban waterways in Perth is quite different from Melbourne and other places in the world. So we created tools that were sensitive to the different regional conditions and also to support decision making over a range of scales. So it's a catchment scales and also a site scale. And importantly, there's a lot of scientific information out there around the world about how best to repair streams or rivers. And a lot of it's embedded in a lot of ecological or scientific literature that's quite hard to read and understand. So it was quite important, part of our project, to kind of pull together all that knowledge from around the world and bring it into one kind of place. Kind of to make a repository for this knowledge and make it more available. So before I go any further, I just kind of want to say that there's 3 tools I'm talking about and that these tools themselves are kind of all interconnected. So you can use each of them as a standalone product, but they all sort of feed into each other as you're working along the pathway of how they're going to create a living stream or repair the stream. A little bit of background first about the urban stream syndrome. So this is kind of the scientific discipline which provides all the evidence that supports our restoration. So we call it the urban stream syndrome. It's really a suite of maladies that most urban streams around the world show, and they're listed up there. Pretty simply, we just take something that looks relatively natural and nice, and then as the city's developing, we've got concerns about flood risk and so forth. We turn it into something that's channelized, highly uniform. We lose a lot of our biodiversity. We get something kind of simple and not that healthy. And now, well, say the engineers were helping us, they're in charge. And now we're kind of in this transition back towards something more natural. And that comes out of a lot of appreciation that we want our cities to be livable. And there's a lot of research now showing that human health and well-being is increased by green spaces and our connection with them. So that's kind of what's driving our transition kind of back. So in terms of stream or river restoration, typically we have a river restoration manual, and that's relatively generic. It kind of works on the premise that in terms of the stream ecosystem, if we fix flow and channel form or geomorphology, that those two things exert an overwhelming influence on everything above it, like water quality, the riparian zone and the animals that live there. So if we fix those two things at the bottom, everything else will kind of hopefully repair. So that's a bit of a build it and they will come kind of paradigm. So these things are most influential. We spend most of our time there and then we spend less time up there. And that's fine, there's nothing wrong with that. But what we are kind of, I guess, increasingly recognising is that we could maybe do better, and we should be really tailoring our management to our regional setting, recognising that there are differences in how streams function around the world. We also know that streams function very different in their headwaters, like a small first or second order creek compared to a really large lowland river. So we want to incorporate all that knowledge and appreciation of regional differences, and then also recognise that around the world there's all different types of urban practices, and there's all these constraints that mean we kind of can't do everything we'd like in an urban drain. And then if we take that all into consideration, instead of this sort of generic guidance here, we could come up with something that's quite a lot more tailored, which could say, you know, for any given site, you know, maybe fix that, maybe fix flow first, then come over and fix water quality. So this is what the Restore tool itself actually does. And before I talk about the Restore tool a little bit more, I just wanted to place it in terms of, in a larger context, so in terms of a framework for repairing these urban streams. And now to start with, at the beginning of the framework, there's this kind of prioritisation component, which is where most of the tools help you with. Once you've worked out what you're going to prioritise on and identified the actions you're going to do on the ground, then obviously you've got this whole monitoring and implementation and evaluation cycle, where you actually go out, monitor, see if you've made any difference, and then maybe change things if you're not succeeding. I know there's often a lot of, well, this requires a lot of money, and often it doesn't actually happen, which is unfortunate because it's really how we learn. But today, the tools I'm talking about are sitting up in the top part in terms of prioritisation. So this is the tool, it's called Restore. If someone can come up with a better title that, you know, the acronym actually means something, that would be great. And so it's about prioritising these 9 different ecosystem components. So we've got flow, we've got geomorphology, the riparian zone, water quality we've broken up into physicochemical, like temperature, oxygen, and pollutants, and then we've got nutrients, just to separate them. We've got biota, there's 3 different types of connectivity. So there's the way water and animals move along the main channel of the river, we call that longitudinal connectivity. And then there's a connection between the flow and the water out onto the floodplain, that's lateral connectivity. And then we also have vertical connectivity, which people might not be as familiar with, and that's recognising that a lot of stream flow comes from the groundwater, and also within streams, water in the main channel dives down through the sand or through the gravel into the hyporheic zone and then up wells. And that's quite important for how streams function as well. So this bit's a little bit boring, but I think it's important just to set the scope of the tool, because it really lets people know the conditions in which it's appropriate. So firstly, it's important to stress that the tool helps managers to prioritise what to do once the restoration site's being decided. So it's not a tool for prioritising sites across your urban landscape. That can be done using other methods, but it's not, the tool does not do that for you. And it's all about answering what type of efforts at this actual given location. So once you've decided this is your restoration site, what should you do there? That's when the tool helps you. It assumes that everyone's already got together and decided that ecological integrity, or improving it, or improving stream health is going to be a goal for your site. If conditions dictate that it's just about increasing human amenity, then these products aren't so useful. It's been designed for flying fresh waters, so it doesn't have information about wetlands, which is a bit of a shame for Perth, because basically we are a wetland. And it's been designed for an urban and a peri-urban context. So it could also be useful in an agricultural landscape, but it's got a lot of information about urban setting feeding into it. Quite importantly and usefully, the tool facilitates dialogue among all the stakeholders about what we're doing on the ground at any given site. And it helps us to document that and make our decision-making process quite transparent. And like I said earlier, it is a repository of scientific evidence, so it can help build institutional capacity about river restoration. And of course, it is just a tool. It's got a lot of assumptions and limitations behind it. That's quite important, but I'm not going to talk about them today. And it can be, I think it's most helpful in data-limited situations where we don't know anything and managers are forced to make decisions kind of just by guessing. But it's also useful in areas where we do know quite a lot about how the systems function. So how does the tool actually work? Like I said, it's a prioritisation tool, and basically it functions, it uses 3 different criteria to prioritise, which is how important is any given ecosystem function to any ecosystem component, natural stream function, how stressed is it by urbanisation, and what's the potential for that component to recover. So think about flow, for example. Is it important for this site? How damaged has it been? And do we think we can fix it? So really the underlying premise is we're going to get the best return on our management investment if we make sure we focus on components that are important, that have been degraded, but that can recover. So if something's important but it's not degraded, obviously why are we going to waste our time? If it's important and degraded, maybe like flow, there's really nothing we can do about it, again, maybe we shouldn't be focusing our effort on those types of things. So to run the tool, it's pretty simple. There's 126 questions in 4 tabs. I thought rather than actually just going through this cut and paste bits on the screen, I'll actually jump to the tool itself. So it's an Excel spreadsheet. And they're all tabs that give you a little bit about the background, again, all the different components that underlie it, how it prioritises. So a lot of the information I'm talking about now is all, again, inside this Excel spreadsheet. It talks about the scope, it talks about the different approaches that you can use the tool. It provides examples of the tool being run. The managers have run it for me. And then detailed instructions on how you actually run the tool. But the important thing I wanted to show you now is that there's these 126 questions, and that seems like a lot, but it's actually not. I think once you've run it once or twice, it'll actually be quite simple to use. And all the questions are grouped into 4 different tabs. So firstly, you have to answer questions about urbanisation in your catchment. So the catchment upstream of the site, there's a range of questions, and they've been grouped in terms of certain, well, obvious or useful groupings. So here, urban development, then urban infrastructure, and there's a simple question, and then there's a few different answers. You can choose which answer is most relevant to you, to your site. And so when running the tool, I think it's really helpful for the practitioner to gather the resources that could help them. So that could be a GIS layers. It could be staff that work in urban drainage when you're kind of answering these urban infrastructure and development questions. Pulling those types of people together around you and then working through. And then these blue cells here are the linked cells. So you choose the appropriate answer, put the number in here, and then behind it, it took him about 2 or 3 hours, but that was for 4 case studies. So it's about 30 to 40 minutes per case study, and I assume the more often you run it, and once, say for example for a city, a lot of the questions will stay the same across your general area, and you don't have to keep answering those questions. So I'm hoping that you could maybe end up running this tool in less than an hour, and given the amount of cost and investment that we spend repairing a site, that's relatively small. I think it's worthwhile. So once you've, actually before I move on to the next tab, there's a spot alongside this where you can put management notes. So you enter the name of your site here and it will populate through. So you can document, and then you can say a note here, had no idea, just guessed it. Or you know, spoke to Ant, she said this. And that's how it actually helps for us to track and make transparent the decisions that we've actually made. And that was recommended to us by other managers to do that. It would be quite useful. And then once we've answered a lot of questions about urbanisation at the catchment, we come down to thinking about urbanisation at the actual site. And again, there's a range of questions here about urban infrastructure, about the riparian buffer, and about physical alteration. You work your way through all the questions. So we can just click in here. That question just says, is wastewater from a treatment plant likely to be altering the flow of the site? So that's not so relevant for Perth, but in places over east it is. So you can see once you go to a question, it tells you which ecological component it affects flow, it tells you which criteria it affects, so it affects stress. And then there's actually explanation and evidence. So for every question, there's an explanation for why it's important, why it affects stress, and there's references as well. So that helps the person using it to learn more about why this is important and actually, I guess, justifies why it's been included. And then once we've done all the urban questions, we come to environmental questions. And again, we run through the same process. So we start off looking at the catchment, running through all of those questions. And again, at the catchment, so some of the different questions will be about climate. Some of them are about the soil type. So, you know, GIS layers about soil will be useful. Some are about vegetation. Some are about riverine conditions. And then we go to the site. Now, when you're answering these site questions, I think it would be great if you had like a tough book or something you could actually be at the restoration site and looking around at while you answer them. Again, and here there's questions about the riparian buffer, the in-stream habitat, water quality. So if you've done a little bit of monitoring and groundwater and the animals that live there, you can answer all of these different questions. And if you don't know, you just put one in. So even if you're not sure, it kind of just takes pretty much the average. And then behind the scenes, like I said, there's these 13 different sheets that you can't see at the moment, but if you go unhide, you can see them all. And then behind the scenes, it goes through all of those different tables that do the prioritisation and then spits out an output. So it's all linked in, everything will be automatically populated for your case study, and the names of the sites that you've entered earlier will pop up, and then it generates diagrams after that. Just jump back to this presentation. And so this is an example of an output that you could get. So this is Gardeners Creek in Melbourne. It's a heavily urban lowland site, and the overall prioritisation score says yes, hydrology is important, and then it says nutrients are the next ecological component that we should be spending our time on. The spider diagram is quite useful that accompanies it because it helps to explain important stress and recovery. So for example, you could look at this site and say, oh, it doesn't really say that fixing the riparian zones are important. We could come over to here and see, well, the riparian zone's really stressed, but at this site, it's actually not that important for stream function, and our potential to recover it's actually quite low. Maybe there's a really narrow buffer around it and there's houses. So that explains why we're not actually going to invest any much effort on the riparian zone. So that should all be pretty simple, self-explanatory. All I really want you to take away from this is that Reese ran the tool for 4 different sites around Melbourne. I asked him to choose things that are really different, so up in the Dandenongs and out in Western Melbourne where it's kind of grassland, so then the riparian zone and the tree shading isn't that important in that type of setting. And you can see here it gives quite different outputs. So that's what we're really wanting, for it to be tailored to any given location. But it'd be great to see what it does across Perth. I would love for someone to trial that. Okay, so once you've run the tool, and you know which ecological components you're wanting to focus on. So then we have to think, okay, so what am I going to do to fix flow, or what am I going to do to fix biota or the riparian zone? So that's where the fact sheets can come in to help. So these are our urban waterway fact sheets, and there's a different fact sheet for each of the 9 ecological components, and for many of them there's a fact sheet for the site, what you can do at the site, and then there's a fact sheet for what you can do in a catchment. And that really recognises that we need to operate at multiple scales to repair streams. And often the things that are most influential will be actions at the catchment scale. Think of the catchment controlling the stream, but there's a lot of jurisdictional issues. Working at the catchment is incredibly expensive and really hard, and I recognise that a lot of catchment groups or restoration groups just can't do that. It's just not practical, right? So then you can just go to the fact sheets about what you can actually do at the site. So in terms of what does each fact sheet actually tell us, this is just geomorphology for an example, and for geomorphology the site and the catchment are actually encompassed inside one fact sheet. But you can work through these fact sheets in a hierarchical kind of order if you like. So firstly it says, okay, I want to fix geomorphology or the way the channel. So there's all these different strategies, there's 7 strategies. So you can look down for each different strategy and there'll be all these big tables that sit behind these diagrams. And note that the diagrams show some of the different actions you can do, so there's nice pictures to stimulate ideas, but I couldn't fit all of the different actions on these fact sheets, so there's a lot more actions that are listed in the tables. So you think, okay, you read all the different strategies that you could do. Actually, reduce flow volume and velocity, okay. And then you come and you kind of read the text and it will tell you when that strategy is most appropriate. So maybe it's not appropriate in your setting. And you could kind of go through all these strategies and cross off the ones that you think aren't relevant or there's no way you're going to be able to do them. And then you're kind of left with maybe all of the strategies, or maybe 2 or 3 strategies that you think are appropriate. And then you come to the tables for that given strategy and you read all the actions. So there's 5 or 10 actions that can deliver that strategy of slowing water or increasing geomorphic complexity at that site. And then there'll be notes about why that action is useful for the stream, and then information on the conditions when that action is going to be effective again. And so you read through all that information, you say, oh, you know, adding rocks back in or adding logs back into the stream is going to increase geomorphic complexity, but it's not unlikely to be really useful where there's really strong flashy flows because I haven't fixed flow in the catchment, and anything I put in is probably just going to get washed away. So then you just start crossing off actions that don't seem appropriate again, until you reduce down to a suite of actions that you think are appropriate and useful, and then you can sit down with your group and think about which of those you actually want to implement. And then there's references to guidelines that can help you actually implement that strategy. So adding wood back into a river, just for a really simple example, you can then go to those guidelines that tell you the right angle to put that log in so it doesn't get washed away. So there's sort of like information nested inside information in kind of this hierarchical fashion, which you kind of just work your way through. I just wanted to stick up some of the different diagrams, which are all in the fact sheets, just because visually it's quite appealing, and just got time to kind of flick through them like that. So in terms of repairing flow, the strategies to reduce flow volume, reduce the velocity, reduce the frequency of flow pulses, slowing the rate of rise and fall, and fixing stream-based flow. And then again, there's some of the actions that you can do at the site to do that, and then those that you can do at the catchment. And then all the actions obviously flow behind these. And then in terms of longitudinal conductivity, what can you do to let water and animals move either in the riparian zone or along the main channel itself? Lateral connectivity, what can you do? The strategies to help the river and the floodplain connect. in terms of vertical connectivity. So again, this is water. It's coming down the main channel to a gravel area and goes underground, and this is where a lot of nutrient transformation happens, these biochemical processes that are kind of like filters in the stream and help to clean the water. What are the things that we can do to help that happen? And in the riparian zone again, all the different important strategies like shading the bank, shading the stream, stabilising the bank, filtration, providing food via leaves into the stream, and habitat. And nutrients, obviously there's a lot of different things at the catchment scale in terms of biofiltration basins and so forth, nutrient-rich groundwater and all those subsurface drains, and then what can we actually do at the site. So a lot of this one's about reducing inputs into the streams, and then at the site it's more about, so if there are nutrients here, what can we do to chew up those nutrients to kind of get the system processing them and stop things getting released from sediments and so forth. And then for water quality, again, all the different strategies we can do at the catchment and at the site. And then lastly, if we're interested in animals, which we often are, what are the different strategies in terms of creating refuges or looking after these really priority or good sites? Remember, this is the canning. These are just hypothetical, they're not actual locations of refuge sites. And then what can we do at the site? So we can also create refuges inside our sites, little backwater places that don't get hit by all this flashy urban flows, improving habitat, obviously getting rid of introduced species, and maybe sometimes we have to bring in our natives from somewhere else if we've lost them, and also protect them from fire. Okay, so that's the fact sheets. I think even if you don't use the restore tool, they're a really great resource in their own right. There's a lot of information inside them, and hopefully they'll be quite useful. So lastly, the riparian guidelines is the last thing we developed. The idea initially was, so we've got these 9 different ecosystem components. The restore tool helps to tell us which ones to prioritise, and then we end up with all these actions. We wanted for each of those ecosystem components to create the guidelines that help you prioritise the actions. It's just so much work that we weren't able to do it in the time we had, but we did it for one ecosystem component, which is riparian, because there's a lot of information already out there, and so it was relatively straightforward to do. So the guidelines themselves just have a lot of information about how riparian zones work and how they're important for the health of the waterway. And we can recognise that riparian zones deliver these 10 different processes that support the health of not only the aquatic environment but also the terrestrial environment. And the guidelines work the same way that the restore tool does. Again, they prioritise things based on importance, stress and potential for recovery. So there's tables inside the guidelines that let you know for your given site, is light and temperature regulation likely to be important for your site or not. So you can work through and score your site for these different, a lot of information about how urbanisation stresses all the natural functions the riparian zone provides, and you can then estimate how stressed it is. Now the good thing is that it's pretty easy to go out to your site and do an assessment of riparian health. So here we've kind of adapted this RARC, which is a rapid assessment. It comes from the eastern states, but there's already a method that's used by DEWA here. And it's really, really similar, so it's easy to go and do that riparian assessment. I think it's in the Galvin document. And then just come up with scores and fill this in, and it will tell you how stressed your riparian zone is. Yeah, of course, looking at factors like natives and exotics, connectivity along the riparian zone, how disconnected or how broken it is, cover, and all of that type of stuff. And then again, we have tables about potential for recovery. So, in terms of channel adjustment, could the channel actually be allowed to move naturally? It looks about the buffer width that's surrounding your urban drain and Obviously, if it's a really small space between the trapezoidal drain and houses, then you don't have much capacity to go in, smash up the concrete and let the system start wiggling around. But if you've got 50 metres or 30 or 100 metres, then maybe you could think about smashing out some of that concrete and letting the channel develop a natural sinusoidal kind of shape. So again, once you've worked through those 3 steps, you get a summary table here where you put in the values that you've scored through the other tables, and it gives you a prioritisation score. And now, instead of just, like when I talked about the fact sheets, it's just all the different actions and you kind of choose which ones you think are relevant. Here, it's actually done in a quantitative way. So you bring in all the priority scores, and they feed into all of the different actions. There's quite a lot of actions you could do to repair the riparian zone. And then the priority score that it gets for the different processes gets put in there, and you come across with the summary score. It's pretty self-explanatory when you start using it. And so once you've actually decided these are the 10 or so actions I want to do to repair the riparian zone, this document has information about the design guidelines to actually implement each of those actions. So this was something that we definitely had managers coming to us and saying, just tell me what to do right here and then tell me exactly what to do. There's so much information, it's such a hard question to answer, but we've sort of gone some way towards answering it by pulling this information together into this document. And it does again provide information about if that action is likely to be appropriate in your setting or not. And hopefully you can just go out and put them into action. Yeah, just quickly, that's kind of the 3 different tools themselves. Before I end, I just wanted to thank the staff from DEWA. So I guess it was Department of Water when the project started, and so Belinda Quinton was very supportive of the project, and Tim Storer has also helped. It was sitting inside the water science group, which was led by Malcolm. And then we've had manager assistants from all across Australia to trial the tool. And I wanted to give a plug to my PhD student, Jen Middleton, because she's doing research at the moment across the Swan Coastal Plain in urban and agricultural catchments. And so her research is going to be coming out over the next couple of years, and it could be helpful. She's looking at the distribution of nutrients in the water and in the sediment surrounding these urban streams and agricultural creeks, if you like. And she's also looking at carbon, where's it coming from, is it bioavailable, and looking at the role of microbes in breaking up leachate in these streams, because it can be important for the food web. So if you do trial the tools, it'd be great if you let me know if it was helpful or not, or you just ring me up and say, I'm stuck, Leah, or maybe even come out and help me, because I'd be happy to. I've invested so much creating these things, it would be really wonderful to see someone actually use them. And then I guess if we get to the point where people are using them and they say they are useful, but there's bugs, and how could we make it better? We could make new versions of them or something if it gets to that place. So just while we're having questions, I just wanted to stick this slide up to say I do other science. I also work in the environmental flow space, so I've worked a lot in the Murray-Darling Basin, and I'm now working in the Fitzroy River. So with Ben Drew's group to come up with science to help us protect some relatively pristine systems. So it's a bit of a nice change from being in a shitty urban drain, I guess. Great, thank you.